Hi everyone, I'm Julia Hyder, Senior Editor with Modern Machine Shop, and I'm your moderator for today's webinar, which is sponsored by Kurt Workholding. Most shops can realize cost and time-saving benefits with a modest investment in a soft jaw work holding upgrade. Today we'll learn how to take advantage of quick change soft jaws in your manufacturing workflow. This webinar will cover types of work holding jaws, benefits and limitations of soft jaws, how to make and use soft jaws, use case examples for soft jaws, and how to integrate soft jaws into your manufacturing workflow. Our presenters are Bill Enstrom, Applications Engineer at Kurt Workholding, and Steve Cheetah, Engineering Manager at Kurt Workholding. Bill has a deep knowledge of workholding as an owner of 3 different manufacturing companies over the past 35 years and is the founder of CarveSmart, makers of quick change dovetail jaws. Bill will share his knowledge around machinable soft jaws and present options for shops to integrate carvable quick change jaws into their manufacturing workflow. Steve is an experienced engineering lead who has been part of Kurt's engineering team for nearly 40 years. He manages the Kurt Workholding Engineering Group and has a hand in all aspects of the division's manufacturing activities and product development. You can submit questions for our presenters at any time during the presentation using the Q&A tab on the right, and we'll answer as many as we can at the end. I also wanted to let everyone know that this webinar is being recorded and attendees will receive a link to the recording via email. So with all of that out of the way, let's get the presentation started.
Hi everyone, I'm Steve Cheetah.
Bill Enstrom here.
We're going to take a poll right off the bat here and ask how many of you guys have worked with soft jaws or work with them daily.
Yeah.
There's a few questions there that we'd like you guys to pick one of the answers, and it'll help us understand what our audience is all about.
Yep.
So for today, we're going to talk mainly about cutting soft jaws for vices. Most shops use vices, and soft jaws are a much quicker, easier way to set up jobs, and we're going to talk more about that as we go. We're going to talk about the types of jaws, the benefits and limitations of the soft jaws, how to make use of those jaws, examples, and how to integrate soft jaws into your manufacturing flow. And then at the end, we're going to take on some questions. So we'll start out with work holding jaw types. There's hard jaws, step jaws, soft jaws, edge gripping jaws, dovetail and serrated. And the next few slides we're going to go through, we'll talk a little bit about those. First off is the standard jaw. It comes if you buy a Kurt vise or a lot of different types of vices. It'll come with these style hard jaws. That's pretty standard use tool room, job shop type jaws. Most of the time they're used in conjunction with parallels. You'd set your part up on a set of parallels, and you would use some type of work stop system to stop your part left to right in the vise.
Maybe square work for that kind of stuff.
Yeah, square work. I guess the jaws. You necessarily don't need to use the parallels. You can drop your part right down on the bed of the vise, as long as you're not drilling through the vise or something like that. So then the next type of jaw is a step jaw. We sell these style jaws. They're hardened just like the ones you see. They're the ones you get with your standard vise. The benefits of these are that the jaw or the step is built right into the jaw. No parallels. Yeah, the parallels are kind of pesky. They tend to tip over. You have to clean underneath them. So there are things like parallel separators that we sell that hold the parallels against the jaws. That helps.
Still not as good as a step or a carved soft jaw.
And you always got to worry about getting something underneath them.
Right.
Where with something like this, you really don't have to worry about that.
You still got to put a stop on it.
Right. You still got to have a stop left to right.
And here's edge gripping. I'm going to talk a little bit more about this. We've got an example of a part that I made in a process where we started with edge gripping and dovetail gripping has become more popular. CNCs, I started this where we used to square up material, square up blocks. If you can grab onto as little amount of material and machine 5 sides, you don't need even a 5-axis machine to do it, but even in a vertical, establishing that 5 sides, getting the most critical features in that first operation, it's ideal.
Yeah.
Get your material a little bit bigger. You're seeing more and more of this. I'm going to show you an example of, there's a picture there of edge gripping. That's a Talon, Mighty Bite Talon grips, where we're grabbing into aluminum, only a 1/16 of an inch. And on the left-hand side, you see a dovetail prepped in one of our PF 5-axis vices. When you do the dovetail prep, it's a much stronger method of doing it. You can really you can break tools before you rip the part out. But if you can get away without prepping it and you do aluminum, that's ideal. It saves a step. So, on the right, there's the serrated or knife edge, and then the dovetail. So I made a part, and I went through a process that we'll go through where we show the dovetail end of it. So,
so let's talk about jaw type, soft jaws. This is a standard double lock vise that we sell. You can buy it with aluminum jaws, you can buy it with cast iron jaws, or you can buy it with the hard jaws like you seen that first vise in that first picture.
and even the CarveSmart integrated jaws directly into this vise.
Yep, that's a new
We'll talk
one.
about.
That's the last screen.
Yeah,
They
high
have to wait
performance
for that one.
soft jaw vise.
Yeah.
Exactly.
Anyway, so this vise, you would carve those jaws to hold your part, be it round, square, funky shape, whatever. You would carve those jaws to hold your part like in a nest, if you would. And you see a little rectangle cut on the 2 movable jaws. That's the no carve zone. You can't carve into that area because that's the workings of the vise are down underneath there. But that whole area all the way around, you can cut into to hold your part.
And so if you got bigger parts, like 2 bigger parts, you can cut right to the middle of that and right to the outer end. And then the no cut zone is because we're pushing these jaws above the bed of the vise. That reduces jaw lift. So if you're pushing below the bed of the vise, you're going to get more lift. So that's why we do that.
Right.
So, and then here's a picture of CarveSmart Master Jaws. This is off of Instagram. Back in the old day, round parts, you'd get an indexing head or a 3-jaw chuck on your mill or a collet closure. Now that CNCs are more out there, you can just interpolate a round in a vise and clamp onto it. So it's slick. Soft jaws are a custom fit between your vise and your part, and parts aren't always square. So the soft jaws are the way to go.
Demonstrate that for you.
Yeah.
But I can't. I gotta loosen this up a little more.
Anyways, that one there. Well, here we're showing soft jaw material. Depending on what kind of part you're holding, aluminum for maybe a short run thing, steel, hardened steel, all different types of materials. So that all depends on the type of work you're doing, and we'll show you some examples of that. This is a 3D printed jaw. One of our customers, they do some molding and they wanted to just assemble. So they were just holding it. They 3D printed a jaw. I thought I'd throw that out there because it's kind of cool. They printed the dovetail on there so it could work in the CarveSmart system. But
that's kind of the new
yeah.
way to do things.
Yeah.
You can print different types of jaws and put them in.
Right. And for assembly, you're hanging on to something weird, carve the jaw and hold on to it. So.
When should you use soft jaws? So maybe you could talk a little bit about some of this.
Not every piece is, if you're doing plate work, if you're doing, there's reasons not to use soft jaws, but for even step jaw, I use soft jaws all the time. So that's why I'm a believer. But short run, long run, if it's something that you got thousands of parts, obviously you look at custom work holding, different things like that. But for prototyping,
short rounds, medium runs,
even I've had people that this is going to be molded eventually. Well, if it's going to be molded, it's usually not square, and they want prototypes. So make them. So examples here, hard parts to hang on to,
Yeah,
simple ovals.
yeah, that one on the right there, that's a big blade. It
Yeah.
sticks way
Five
up in the
axis.
air. You got a good grip on it there.
Right.
So it's a good way to machine a part like that.
Absolutely.
It's a tough profile there too.
Right. Yeah, it's not
So,
coming out.
Yeah, it'd be hard to
So-
hold that in just a set of standard jaws.
Right.
So, and I think we're going to talk more a little bit as we go about material for the jaws and so on.
Yeah.
So as we go, we'll discuss that a little more.
And this is a good example of like the old school, parallels with
Parallels with the hard jaws.
with the work stop and
Yeah.
I hate that setup. And the one on the right is, of course, to make your soft jaws, machine the stop in there. So you see that we're on, the stationary jaws should have the stop left to right,
Built in
laterally.
Do we got
Yeah,
that? We
I've
got
got
that right there.
I've got
You can
one
kinda see
here where we'll talk about relieving the corners in a few slides from now. But you can see the old Vice and then the CarSmart integrated system on the right, which is a great way to do it. So
Yeah, I like that the work stop's built in. It's a positive stop every time.
no
It's-
chips under parallels.
No chips. Yeah, it's easy to blow off the step.
Yeah. Exactly.
It works great.
So I made a clamp here, and I did we took pictures as we went of how we set it up. These will end up being investment cast, or we wouldn't have made them this weird shape, but it made for a good example of how to cut soft jaws. I've got a 300 millimeter Kiwa horizontal. This is a 4-inch cluster tower on that. That we put the CarSmart Master Jaws. Soon we'll have the cluster towers integrated with the CarSmart features directly in it. But I'm showing how we took this part from start to finish. These happen to be steel jaws. In fact, they're right here. These jaws that I made, I took them off there, and I wasn't afraid to take them off because they repeat, they relocate, they'll go right back in, and I'll continue to run. So that's another great feature about these jaws. So
We should talk a little bit about that, about the pockets and the.
Yeah.
So on a Vice, your movable jaw is allowed to rock. They're designed to rock 15 thousandths or so, and you can get, if you put 2 pockets in like so, the jaw will actually rock so that you conform to both parts. If one's slightly larger than the other, that jaw rocks. It'll hold both of them tight. Now, if you're to put 3 pockets in this jaw, you might end up spitting apart because you're only going to hold on 2 of them.
Yeah.
So
unless it's plastic or something, you can kind of squish them a little bit, but
Yeah.
you don't wanna do that.
yeah, the different ways to do that, but
Mhm.
it's something to consider. Don't get carried away making a whole bunch of pockets in the jaws.
Yeah.
You think about
One or two.
1 or 2. Yeah.
Right.
Yeah.
So, the benefits of them, they're accurate. They, you've custom made a jaw to your part. They repeat. There's no parallels to, you can run four parts in parallels and then get a chip on it and scrap the 5th part.
Yeah.
So they're rigid. You carve the features as deep as you can, get them in there as far as you can. So there's more rigid. You wouldn't, stick a tool out any further than you'd need to.
Great.
And they're self-aligning. They only go in one way in a lot of cases. So, and it's a low cost solution then, to custom fixtures and things like, essentially it is a custom fixture, but it's a soft jaw. So
Great. It's a cheap custom fixture.
it's a cheap custom fixture.
That's the great thing about it.
They
It's
typically
the low
don't take
cost.
long to make. And yeah. So
Does it make sense to use soft jaws?
doesn't it?
Yeah. Well, there's times I think,
1/8 inch sheet of Delrin.
Yeah. Yeah,
You're gonna vacuum chuck. You vacuum that down,
maybe some fancy casting or
or you're making a DX6,
yeah. You're
You're
making
using
a brace body. It's a little tough.
big hydraulic clamp fixture.
So it lends itself well, I think, to a large variety of parts, but not everything.
Not everything.
So,
But in a job shop, a tool room, when you got vices, soft jaws are the way to go. It's quick and easy, and then you can determine how much how, if you want to go steel, if you want to go aluminum. So, but when doesn't it? Obviously for weird parts, big parts, stuff like that.
yeah.
And how you determine? I always look at everything soft jaw first.
Soft jaw first.
Look at everything.
Yeah.
Soft jaw first. So, what are the part and job requirements? The first thing I look at, when you're quoting something, you're going, all right, can I hold this in soft jaws? How am I going to hold it? How am I going to price it? So you go through all of that. Yeah, aluminum. Am I running a bunch of steel parts? Are there going to be chips that are going to get impregnated into the surface? That can be an issue. Then you want to go to something harder. So you want to, how many are you going to do? What does it look like? And where am I going to go from there? But I always look at it through the lens of soft jaws. So.
Soft jaws. But I do think the material that you're machining, the life that you want to get out of it, all determines what your soft jaw is made out of.
Right.
And then we make jaws out of aluminum. We make them out of a steel.
Mm-hmm.
So you can go
Hardened steel. 50 Rockwell.
Right.
Yeah, 60. Yeah.
So you can do different types of materials for different applications.
Right.
This is I believe this was the AR400.
We
So it's
started
like-
with that.
Yeah.
And we went to
Something a little
4140 pretty
yeah.
hard.
But we
40
started
Rockwell
with
stuff.
with this,
Right.
and you used a nice steel jaw to hold this because we are going to make a lot of these, and it is a very tough, hard to machine.
Right.
A lot of maybe smaller, finer pieces, chips coming off. Those would get embedded right away in the aluminum.
Yeah, even though
So-
you're blowing them out, they get stuck in there. So, how will it be machined? Am I going to get a drawing, a 3D model, a napkin sketch?
Napkins.
Yeah, the engineers. And then what machine are you going to use? If you have the option to use a horizontal, can we get at it from a couple sides? Do we want to, put it on that machine or vertical? So that's what you're going to go right out of the gate. And then if you get a drawing file, you can then easily make the soft jaws because you already got that geometry. So.
Great. So now we'll talk about how to machine the soft jaws.
Yeah. So, and we're kind of using this part as an example, and
Just a simple job that we actually just started running the other day.
Yep.
So
how to machine soft jaws? You're going to figure out what you want to get at first, or how you want to hold on to it first, to decide the jaw. Is the part 8 inches long? Is it 6 inches long? How big can I get 2 in it? In a soft jaw. So you're gonna decide on the size, and then determine the jaw opening. If the part is 8 inches, you're gonna have to open them up, 7 inches or so, and then put a shim in there, and then cut the feature in there and drop it down in there. If they're small like this, I like to hang on as much as I can, so I use a smaller shim. And when you do soft jaws, you put the soft jaws in there, you clamp onto something. You got to get that movable jaw rigid and replicate locked in place, and replicate then the pressure that you're going to hold on it, and put the shim at the right height in the jaw where the part is.
So for an example on this one, Bill, you would have your shim like right in this area.
I would.
So even where your part is, right?
And you'll see I used 2 washers in there. Actually, I had 2 washers right in there. But yeah, what you want to do is when you tighten a vise, no matter what kind of vise you got, you're going to get some distortion. If the jaws are tall, the jaws may want to tweak back. There is going to be a little bit of jaw lift, it depends on how tight, you do. In steel jaws, so what you want to do is, if you can, use a torque wrench. Torque that down to the same pressure that you are going to clamp your part in. That way, when you put your part in there, the vise reacts the same way and it doesn't distort. And then the geometry that you cut in there is perfect for that clamping pressure.
Right.
And I'll show some visual illustrations here. But and you want to put the part in there as deep as you can.
Right. That'll help stop lift.
Yep. But a lot of people will put a small, like in this job right here, they'll put a small 1/2 inch parallel on the bottom and clamp on it. And that's not the right way to do it, because then when they clamp up here, there's going to be a little bit of this, so you want to put that shim up there. And then, like I said, don't just lightly clamp on it the same that you're going to do your part. And that'll produce a better soft jaw. So, and then here, excuse me, cutting the jaw. What I did, one thing, if you've got square corners in your part, very difficult to make square corner unless you're broaching it in there, right, in the pocket. So I showed how I brought the drawing in here, but I used a 1/2 inch cutter to make these jaws. And you see that I relieve that corner. And not as dramatic as relieving like these corners, but I put it on there. I planned the gap. If you see the 2 lines there, I planned the gap on that one, so I didn't have to relieve that corner because that's in the gap.
That's pretty smart.
Yeah, a little thinking there. and put that in there and just pocketed it out like that. And you want to use a square end mill. Don't use a bull-nosed end mill on the bottom, because in the bottom of the pockets, you want a sharp corner. In this case, I chamfered this 15 thou, which would allow for room for a radius in the bottom. But if you've got a 15 radius and you've got a square edge here, it's going to want to rock up. And so you want to make sure that you get a square end mill, relieve the corners out, and have that square corner on the bottom. So yeah.
That's probably the biggest thing is you don't want any radiuses at the bottom of the pocket.
Yeah.
And when you got a square corner like this, it goes into a pocket like that.
It's got a place to
So it's got a place to go. Otherwise you'll be sitting off and you won't clamp your part the same
Right.
every time.
And it's a place for chips to, so the chips don't get in there too. And it's a better way to do it.
Yep.
So when you're making soft jaws, essentially you're making a part to make a part. You're making, and you'll see I grabbed a couple of washers. When you're doing your shims, you want to have something that you can cut into too, because you're putting them in the area high enough where the part is. That's what I like to do. So if I'm cutting aluminum jaws, I like to put aluminum or a penny or something that's not too tough in here. I used washers that I ended up cutting into and threw away. But we're finding zeros. We're putting the soft jaws in there, and we're cutting the female feature in there. So, and here I'm just showing me setting it up. So
You didn't cut that washer away, did you?
I cut half of it away
Cut it half
on each of them. So
Okay.
yeah, you don't want to cut the whole washer out of
Yeah,
there,
that'd
or you
be
got
a
nothing, or
problem.
you're not clamping on anything. Right. So, but something low cost. And here, I'm showing them after I put the parts in here. On this particular part here, I'm showing it in the dovetail how I started this job. But when we flipped it over, we cut that off on these soft jaws here. And you see on the view on the left hand side as I come around, I 3D milled the chamfer as that hole exited that 45-degree
It's a nice chamfer.
surface. Yeah,
Pretty fancy.
under 10 seconds. So that wasn't bad.
All right.
But yeah, that's now that's replicating exactly how I clamped onto it. So here, Steve just showed you the jaws. So what I'm doing first is I'm taking a saw cut part and I'm putting it into this operation to put the dovetail on there. That's just 60 thou deep. It's a simple dovetail. I use the 40-degree included. But what that does is it allows me to get that underneath this talon. And these talons aren't actually they're more to bite, but they hang on to the dovetail. And you can see that I'm 1.1 inches above in pre-hardened steel with a 1/2-inch cutter, and haven't whipped one out yet. So, and I'm being aggressive. I'm not, they hang on. If you can grab onto a ledge like that, they hold on. So in this first one here, relieving the corners out, I'm putting them in rough saw cut. I just hit them on the belt sander, and then clamp them down, prep them. Then they go from here to there. So
I think there's a couple more slides that kind of show the progression.
yeah,
So that'll help to
Right.
explain this as we go.
sure. So, and then the next slide here, we're showing. So this jaw I made pre-Carve Smart, so it's more than a dozen years ago. It's a real jaw. I used it. I made parts in this. I had a job shop. And you can see 2 pockets. You can see where I did two parts here and 2 parts here, and a part here. Ideally you hold 2 parts. If you're talking 2 small parts, which I did a lot of, the sweet spot is right where the cap screws are.
Right.
Right there is where you want to hold the 2 parts, and right there is where you can't, because
Yeah.
the cap screws get in the way, and are you cutting into them? So the Carve Smart system, once you get that in that master jaw, everything is machinable all the way down. You don't have to worry about it. You can put the parts where you want. So I prefer running soft jaws a fresh one every time, but we do have the relocation feature, and depending on how many you're doing, these obviously I'm gonna save and reuse. They're gonna last and last and last.
That's what that pin is for.
Yep.
It locates the jaw in the master.
And that rest on the dovetail,
This
so
is-
it relocates very accurate.
Right.
And like you said before, something simple like this, you could do a dust cut on that again and take out any after
Yeah.
you've used it. So
Yeah, just clean it up.
reuse it.
again.
These you can
or-
flip it over and use the other side. So
So you buy a set of master jaw or aluminum jaws, what's that around about?
Yeah,
Just
like
roughly
these are $30 a set.
30
you
bucks
know?
a set. So you buy that and you can actually run 2 jobs in it. This is
Yeah.
pretty low cost fixturing.
It is. It
You know?
is. And the CarSmart system, actually, we sell extrusions. You can cut any length you want. You can cut a 1-inch piece and put 2 1-inch pieces right here and hold one part in there. You can string vices together, and we'll talk about that a little later too. But you know, here we're showing this particular job, how we came from just saw cut. We put the dovetail prep on it. We put them into the Talon jaws here, and we machine 5 sides, and we access the one side and put the hole in it. I actually put the hole in it before I milled the feature on it, so I wasn't exiting out that 45-degree hole with the drill. And then, you know, we flip it over. So, you know, step 1 is using those jaws, putting it in there, getting the dovetail. If this was aluminum and I could get away with just dripping it with serrated jaws, I would omit this step. But hardened steel, I want to make sure that I'm hanging on to it. I'm not winging it out, breaking tools. So, and then of course on this, and I have a tombstone, so it was great. I have everything set up, just the progression. I got 4 parts coming off done, which is nice. Clamping on to the dovetail, and I'm using, like I said, I could have milled a dovetail jaw. I could have taken a steel jaw and cut a dovetail in there and made it that way. I like these Mighty Bite Talons. We sell a ton of these jaws. These are the Versa grips on there for holding round parts. They work extremely well. So I'm clamping on to 2 of these with the dovetail. I mill this side first flat, drill the hole, mill the perimeter, come back, chamfer that, chamfer the top, face mill, and then that step. So steps 2 and 3 are done in this operation.
Works pretty good.
It works slick. And then 4 and 5, when we go ahead and put this in to this here and clamping on this, we machine away the top. And I don't just take a face mill that, then stuff bad happens. I come in with an end mill, and I come in on top about 10th thou above, and I machine the perimeter of that, and that just rolls right off. Otherwise, if you take a face mill to that, it'll
Tear it
yeah.
out of there.
So once I get this off of there and it just falls off gently, then I take a face mill to the top, and then a 45-degree cutter come around the top here. But then also I had access, and I relieved this out. You see that there, and with a ball end mill, and I just danced around there. And then when it comes off completely done.
Yeah, nice.
And works like I said, these will be investment cast. We're not going to do this long term, but until we get that tooling made and done, we're going to do it this way. So,
Yeah. Good.
So
Soft jaws can benefit diverse shops, and we'll talk a little bit about the different types of shops
yeah.
and you know how they use jaws.
Yeah, we want to talk. We just broke everything into 3. You know, big, medium, small, and we'll talk about them. So, like a large OEM shop. So, like some of our customers, our customer customers, are Facebook and Tesla,
Nike,
Amazon.
Amazon.
You know, so
Yeah.
here, you know, you think about Amazon. Well, what are they machine? Well, you think about they got to have a maintenance shop. You know, probably a full machine shop, and they're trying to fix stuff. You know, so in their tool room where they're prototyping, where they're doing things, they're fixing things, they're making fixtures. They're actually not as big a consumer as more the medium-sized shop is, at least in my experience that I've found. But dedicated fixtures for a large shop, they're making components to build massive fixtures or fixtures and horizontals and things like that. So that would be kind of the large shop.
You know, Kurt kind of falls in between A and B there.
Yeah.
You know,
Yeah.
so at least our division of Kurt. And we use them a lot in our tool room for prototyping.
Right.
You know, 1 to 10 off at a time. It's
Right.
a quick setup. Saves us a lot of money. You know, it's just
Well, even we used to, you know, machine movable jaws and stuff at cluster towers with soft jaws on.
great,
You know, and that's kind of how we make them. So,
great. So
so yeah, and then you know, the mid-size shop, job shop. That's what I've been doing most of my life. Has been job shopping, kind of the bottom feeder quote and stuff, trying to get stuff through the shop. But you don't know. You know, the guy wants you to quote 1, 10, 20, and 500. But of course, he doesn't want to. He wants the 500 piece price for the one part because he wants to try it. So that one you want to get in, get out. You know, get it quoted as low as you can. Make something that could you just throw away. You know.
Right.
But there again, you do anything and everything. You don't know what the job is that you're going to see. So soft jaws are great.
you know, we talked yesterday a little bit about carving your pocket right into your CNC program, and then skipping over it when you're running the parts.
Yeah, we've got customers that use a new set of jaws every time. They have a program to cut the female feature and then a program to run the part. And if you do a good, accurate job, some of these people don't even find zeros again.
Yeah.
The machine knows it's here, and the machine goes back to that location. And like you said, you either have a sub-program call on the front of it, or
skip it.
and resident tools, soft jaw tools that are in your carousel, which are typically non-complicated, complex.
Yeah.
So
probably some of the same tools you're using to make the part.
Right. Yep.
So.
And then, the small shop, the garage shop, the knife makers, I've found, with CarSmart, there's a lot of people making really cool knives and things like that. Little weld shops, making little key holders and things like that. And soft jaws are just a simple, quick, easy way. You can start with a vise and just, cut that in there. And we talked about assembly, things like that. Work really slick. So I guess in all size shops use soft jaws.
All size shops can use them.
You bet.
All right, we'll take a few questions.
If you guys have any questions, we can take some. And is this Mark Harris? Jaws repeat when removed from CarSmart and replaced plus or minus 1/10 or question mark.
Huh.
So the way we make the CarSmart is on the dovetail. So the CarSmart jaws do not rest on the bed of the vise. They rest on the dovetail. So and here's one actually with a pin. So the dovetail, we have a 1 thou plus or minus 5/10 from the bed of the vise up. So what you're going to get is in Z, you can get a max of 1 thou. In left to right, you're going to get 3/10. What we do is, this is a standard +1 +3 dowel pin. I have a Deltronic 25 pin quarter set, and I go +4 +7 won't go in. So we got about within 3/10, and our customers have told us it repeats, just spot on. Now, if you, like I like to do, is number the opening that it goes into. I've got 2 vices on a Kitamura. I've got A vise, B vise, and it's a double station, the Trilock. A1, A2, A3, A4. I stamp my jaws. I go back in there, and they're right on, absolutely right on. So they repeat really, really well. We've invested
heavily into the MLH 35s, ML35 hydraulic vices. Do you have soft jaw blanks for this product? And I don't believe we do at this time.
I don't know. I don't know what
because that has I think a 3.5 inch hole spacing.
Okay.
I don't know if the
4
inch would work on that.
I don't know.
It'd have to be something, Mark, we'll have to find out.
Yeah.
And let you know.
And maybe it's something that we need to make.
Yeah. It's always something
You bet.
we need to make.
You bet. Andrew, what is the price point for a set of CarSmart jaws? What do you get with it? And are there different package deals? Well, so this is our most popular. This is if you've got an existing vise. We've been selling this, one of my companies, and I just came on with Kurt 5 months ago.
Yeah.
And now Kurt owns CarSmart. This is a 4140 pre-hard. They're ground flat and parallel, and this is $295 for a set. It comes with a wrench, 4 low head screws, and it will bolt right in. And then you can pick from an array of jaws. We've got 5 different profiled aluminum extrusions. They come as long as 94 inches. We'll ship you in a tube. I think our and of course they're price based on size. We've got a 2-inch by 3-inch. It's 63 pounds, and that's about $300. But and then they go as low as 3/4 by 2 inches high, and I think those are in the $20 some dollars. But this is kind of the starter kit, and we don't have a package really because you can pick what you want. We have customers that will buy this, a set of Talon grips, and a set of soft jaws, so they know they can go 5 sides, flip it over, and go in there. So, and that's all on the Kurt website, and CarSmart. The CarSmart.com is up too right now. So,
Cool. Do you recommend using a shim with soft jaws when machining the actual part to mitigate jaw lift?
Well, I see what you're saying. You're saying put something in the bottom and something in the top. And I wouldn't recommend that, because if the shim is bigger than the part's going to come winging out. What you want to do is, you know, put that shim where the part is going to go, and replicate the lift. If you've got the shim in there and you tighten down, and you're going to get jaw lift, then machine the feature in there, and then when you put the part in there, you've replicated the lift, and essentially you mitigated that.
Right.
So that's why I say put that shim as high as you're going, because if you're holding, if you got tall jaws, you put a part in here, it's going to go like this. It's physics. It's physics. But if you put the shim up there and you make the jaws go like this, and then you cut a perfect feature in there and use a torque wrench, you're going to get the same thing. It's going to repeat. We can deal with repeat.
Great.
Can't deal with error. We can deal with repeat. We can make a move. So that's what I would say to that, Lisa.
Yeah.
And yeah, so if you guys have any more questions, you can certainly reach out to me here too. I think my email will be in here. And here's our brand new, I'll throw a plug in.
Yeah.
High performance soft jaw vise.
High performance.
High performance.
I like it.
It's CarveSmart integrated. It's ready to go. This happens to be a 3-in-1. It's a small single station close to the operator on the y-axis. You got a 20-inch machine. You don't want to lean into it to get that back jaw. You want the back jaw to come forward. Here we have no deflection. We're opposing force. Minimal jaw lift, because we're above the bed of the vise is where we're pushing on it.
The angle lock concept.
With the angle lock concept. And then we go to a double station. And then we go to a huge single station. Without the jaws in there, it's over 12 inches. So you can lay on the bed, and it disassembles quick and easy, and ready to go, and they're ready to ship.
And we should talk a little bit real quick about how the jaws bolt on. It's like a precision bolt, often used like in a Carlane grid system.
Sure.
1/2-inch shank, 1/2-inch thread, goes through the stationary jaw down into the vise body, locates in the vise body, tightens down. Very tight tolerances we hold on that.
Yeah.
Very accurate vise. And
these jaws, the movable jaws, are quick disc. They quick snap
they pop
off.
off.
So they pop off and they flip around, and they have 1/2-13s. So if you've got a bunch of regular cap screw jaws, you could still use them in this vise, and then progress into the other, and then all your other vices you can bolt on the adapter plate so that you're all CarveSmart. The whole shop is CarveSmart.
great.
So that's our new vise, and here we go. Here's a question.
Okay, so with the Tri-Lock vise, can you mount a regular vise jaw on the back like a regular Kurt vise?
I beat you to it. I explained that. You bet. So in the center jaw, we have 1/2-13, so you could bolt in your jaws, and on the outboard part, you could bolt in 1/2-13s, and they're ready to go.
Yeah, the jaws just pop off, rotate
around,
and snap it down.
Yep.
Now the stationary is a little different. We have holes in the stationary that will accept.
I should have grabbed one.
Yeah, we should have.
But the 1/2-13s are 3 7/8 spacing, just like the 6-inch vise, so your jaws will go in there.
Great. So, thanks for the question.
Yeah.
How much does it cost to make a set of soft jaws?
Well, the soft jaw material itself, like I said, is just kind of priced based on, like our aluminum jaws are based on by weight. We're pretty much buying it by weight. So the price, of course, you get bigger soft jaw, it costs more money. Steel ones, and by the way, you can make your own jaws too. It's just a dovetail. So depending on how much work and how much time you got into it, I think a set of these are in the 20s.
$20-$30.
Yeah. And some of the bigger ones are going to be more.
You have to make the initial investment to buy the master.
Correct.
Or buy the Tri-Lock vise.
Yeah.
But once you make that investment, the jaws are really fairly
reasonable.
Cheap.
Yeah, when you're probably using an $80 cutter.
Yeah.
So
yeah.
So it's pretty low cost.
That's
and
great.
Then can I tie multiple vices together? And this is where the CarveSmart is pretty slick. Maybe David, grab me that extrusion over there if you could. One of the best things about tying, if you're doing long parts, what's pretty slick, we have this extrude. This is one of our more popular. This is a 1.5 by 2. But you would just drop this in the back jaw, and then you'd cut another piece like this, put it in the movable jaw, jaws on say 3 and just slice them apart so they move independently. So tying multiple vices together with the CarveSmart system is, if you've ever done it with cap screwed, you know that they have to be in exactly the right spot and they bolt in here. And I guess here we do have
And here we go back to the CarveSmart,
the Tri-Lock.
the Tri-Lock jaw. It has the CarveSmart in the one side, but you can pop that off, rotate it around, pop it back on, and it has standard holes to bolt a standard jaw in.
Yeah.
And then the stationary has holes in it,
Right.
where you can bolt
Mount
the jaw
it
right onto that, or you can use it again as
Right.
with the CarveSmart jaws.
It's versatile.
It's very versatile.
Yeah.
You,
Yeah.
you lose a little bit of opening because this is a little wider
Bigger.
than
But
our older ones.
You don't have cap screws to dodge,
You don't
so you
have
get it
cap
right back.
screws. Yep.
So, and then another,
And
go
I think
ahead.
we should say too that we have hard jaws for this, like
you bet,
kind of like in the
dovetail
picture,
hard jaws.
dovetailed hard jaws. They're only 1/2 inch thick,
Yeah. Instead
So-
of 3/4.
so it saves you the time of taking out the cap screws, unless you got pre-carved jaws already on the shelf from other jobs.
Yes, you can bolt them
You
right
can
in.
bolt them right in.
You bet. You bet. And then I guess another, do I need to cut new jaws every time to run a job? Not necessarily. It depends on, if they're pinned, because if you get extrusions, sometimes you don't even pin them. You just cut it, run a new pair every time if you want. But if you want, you can install the pin yourself. You can buy them pre-cut, but you don't need to. No, not necessarily. So, and then what?
How long will they last, wear, and tear?
It depends on the material and the part, and you're blowing them out.
Yeah.
They can last forever. These would last forever.
It depends a little bit on the operator too. If they're
Right.
very careful, make sure they get all the chips out all the time.
Yeah.
They're not going to get beat up. So
Right.
I think that's kind of it depends,
Right.
kind of a question.
There you go. There's another question.
Does Tri-Lock come in hydraulic configuration for cobot machining tending? Right now, we do not have the Tri-Lock in hydraulic. We have our HD series double lock vices, but they're not.
But they're
not
very close.
hydraulic. Yeah,
Because
the
we're
vices
going to make
are
these
set
for the existing
themselves.
HDLs too.
Yeah,
So yeah.
look for it down the line. I think.
Mm-hmm. Yeah. Send us an email and we'll let you know when it's ready.
Yeah.
So. All right. What do you think?
Any other questions from anyone?
You can always reach out to us too here. So we're here for you.
Yeah.
I think that's all we have today. I want to thank Bill, Steve, and Kurt Workholding for making this webinar possible. And thank you to everyone for listening in. You should receive an email with a link to the recording soon. Thank you for your time and enjoy the rest of your day.
Thank you.
Thanks.